So this problem is from bending stresses. Let's work out how to do. So what they're saying is this is a kind of beam which is given subjected to bending moment about x-axis. Calculate the thickness T channel in order so that the bending stresses at the top and the bottom of the beam will be this. Now, if you look at this figure, what we understand from this figure is on the upside, the top side, it is sigma C, that is compression, and sigma T, that is tension in the bottom side. So what we'll have to do is we'll have to take that ratio. So we know already what we know, sigma by Y is equal to M by I. And obviously this quantity is constant, so we can say it is constant into Y, right? Otherwise, what we can write is sigma C upon YC is equal to sigma T upon YT. That is what we know. So if we go according to this ratio, it is saying at the top and to the bottom. So what is at the top? Top is sigma C and the bottom sigma T. It is 7 by 3. So can we say it is equal to, now if you work out with this, what it will be sigma C upon sigma T, it will be Y C upon YT, right? So this is also equal to YC upon YT. Okay. So if we know that, so if you consider this equation, यहाँ से we will get YC is equal to 7 by 3 of YT. Okay. Now, YC, if you see, this distance is YC and this distance is but obvious YT. Now, यहाँ पे दो unknown factors है. Can we convert it into the single factor? Yes, we can. कैसे करेंगे? What will be the value of YC? What will be the value of YC? The total distance is 250. So can we say 250 minus YT is YC? Look at this. This total distance 250. It is YT plus YC is equal to 250, right? So YT will be equal to 250 minus YC. So can I write this equation? Can I write this equation here as 250 minus YT is equal to 7 by 3 of YT? So if we work out that, I will get YT is equal to 75. That we already know. Okay. Now what we have to do is, we have to find out the value of T. How we are going to get the value of T? So for that, look at this. If I split it like this is T, this is T, and this is, how much will be this total? It will be 600 minus 2T, right? This distance. So let me put it here. This will be 600 minus 2T. Okay, fine. And obviously this is also going to be T. So this distance will be 250 minus T. This distance will also be 250 minus T. So what it will be now? And where will be the center? So we know that the centroid will be at somewhere 75 from bottom. From bottom. Okay. How do we work out with the centroid? We work out with the centroid at, let's say, y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2 blah blah, right? So we're going to use the same formula. So 75. Okay. Now let us split it into the areas. What will be the areas? So let us say we can split this into, let's say, this area. Okay. So this will be 600, right? And this thickness will be T. So it will be 600 into T. Where will be CG of that? It will be from here, from bottom, it will be T by 2 plus. Now this area and this area is same. And what will be the height? 250 minus t. Okay. So I'll multiply by 2 itself. I'll multiply by 2. And what will be the area? It is 250 minus t into t. Okay. So that is the area. And what will be the y bar for that? The y bar for that will be 250 minus t divided by 2 plus t, right? Because obviously the centroid will be here, right? So how much is this distance? It is this. So that is divided by 2 and plus this t, okay? Divided by area is 600 into t plus 2 times of 250 minus t into t, okay? So if we work out all this value by permutation and combination, we will obtain t value to be 50 mm.